which time slot, in which frame, in which multi-frame, in which hyperframe it is sent, determines to which receiver it goes. So basically, you pre-configure mappings, which particular time slot on the air interface gets delivered to what particular subscriber. If you do not know this kind of setup, if you don't follow this setup, you will not be able to make any meaning, like what is this data, who does it originate, whom does it go to. This is all out-of-band information. So this makes it very different from other things that you might have been working before. The GSM Network Architecture has a number of core elements, and I'm introducing this terminology also in this presentation to be very clear and to use the same terms that everyone else uses that deals with GSM networks. So the phone is actually called MS. It's the mobile station, and what you generally call the cell tower is the BTS, which is a base transceiver station. And that base transceiver station connects to, over a wired interface typically, it connects to a base station controller. And the base station controller itself connects to the mobile switching center. So you have a hierarchical structure where many phones access one BTS, and a group of BTSs accesses one BSC, and a group of BSCs access one mobile switching center. And then you have auxiliary elements such as the home and visitor location register. I'm going to talk a little bit about the individual elements here. The BTS, as the name indicates, it is a transceiver. Many people call it a base station, which I personally think is not entirely correct, because it doesn't really do much. It's really just a transceiver. So it receives a packet on the air, and it encapsulates the packet into a different protocol and sends it off on a wired interface. And if you get a packet from the wired interface, then it decapsulates that and sends it onto the RF layer. So apart from scheduling the time slots and configuring transmit power and these kind of things, it doesn't contain any protocol intelligence. It doesn't know anything about calls or phones or any of that sort. So basically, you can think of the BTS as nothing else than a remote Wi-Fi card that is not inside your PC, but it's this big box sitting over there, right? And instead of plugging into USB or plugging into a PCI bus, it's this Cat5 cable that runs to this box. So yeah, it is a transceiver. It handles the layer 1 and some parts of the RF layer 2. It handles actual modulation and demodulation of the RF signal, the time multiplex, the scheduling of frames. But as I said, a true slave to the base station controller. The base station controller is the actual instance that manages the radio resources, that determines which channel to use for which subscriber, do the allocations and these kind of things, resource management. It does most of the actual decision making when it comes to utilization of your RF layer. It controls the BTSs, and it also handles handover between BTSs that are connected to the same base station controller. So if you have, like we have here, we have two base transceiver stations. They are connected to one base station controller. And the base station controller would be in charge of noticing if a handset and a mobile station moves from one BTS to the other. The mobile switching center is taking care of the calls itself. So if you make a phone call or you receive a phone call or anything like that, the actual call control protocol is terminated at the mobile switching center. It is also taking care of what the protocol specification calls interworking. I've also read international interworking before, or inter-protocol interworking. So basically meaning that it is some kind of interface to ISDN or other telephony systems, and it does things like handing over calls between multiple BSCs. You have the HLR and VLR, which stores the data about the subscribers. As you know, in GSM, you have a SIM card, and the SIM card is basically, it represents the subscriber to the network. And the home location register stores the information about which SIM cards the operator has issued, and and whether those subscribers are currently attached to the network or not, which MSC they're using, and so on. Also, the visitor location register handles visitors, such as people roaming in from other networks. Let's look at the individual interfaces, just the ones that are important regarding this running your own GSM network business using OpenBSC and like we're doing here. First, there is the UM interface. UM is the air interface between your mobile station, the handset, and the BTS, the only RF interface specified in GSM. The layer 2 is derived from the LabD protocol of the wired ISDN world, and the layer 3 is specified in GSM technical specification 04.08, and it handles stuff like radio resource management, mobility management, and call control. The interface between this BTS and the base station controller is called A-bis, and it uses an E1 physical layer, which is this primary RAID interface ISDN, which has 30 usable time slots, 64 kilobytes each. People who have used the ISDN in larger scale before will know the E1 lines, 2 megabit total bit rate. On this physical layer, there's a layer 2 management TEI entity that is very similar to what you also use in traditional ISDN. So this TEI establishment procedures and that kind of stuff, which you see on a typical ISDN D channel. In addition to that, you have 2 more protocols. One of them is the OML, the organization and maintenance layer, which you use to set up the actual BTS. You configure things like what is your maximum transmit power, what kind of frequency should the BTS be using, what is your channel configuration, all kinds of information like that. You set over the OML layer. Also, this is for event reporting in case of a failure, like your BTS says, oh, somebody disconnected the antenna, I cannot send anymore. You get an event report. Also, stuff like changing the BTS firmware. This is all organization and maintenance layer. The actual interesting part during operation of the network is the radio subsystem layer, the RSL. And RSL is used to actually open and close channels, to configure the encryption that is located inside the BTS for the air interface, and so on. This is for the signaling part. The actual voice data is transmitted in what is called TRAW frames, or TRAW frames in English probably, it puts those TRAW frames into other E1 time slots than the one it uses for signaling purpose. So this is a slide about the time multiplex on the ISDN primary RAID interface. You have 32 channels. One of them is used for synchronization and error handling, and the other channels you have available for actual payload data. Every BTS uses one of these channels for the signaling, OML and RSL, one of these time slots. And then you use, for every 4 on-air time slots, you use 1 additional E1 time slot on the wired interface. I'm skipping that. You can look at the details of the presentations later. So this RSL, it contains messages for the radio link layer.